bike right here just made 58 horsepower at the rear wheel. That's a pretty damn good number. Horsepower is really what matters. Yes, it's midnight and I'm in the garage in my slippers and shorts. Got the heat dish to keep warm. That all makes sense for sure. Couldn't wait to keep going on this thing. It's just too damn exciting. Pulled my side cover off. Basically swapping out some phase wires. Just thought I would mention it in the video quick before I forget. This is the shield from the one phase wire. There's a piece. No. Just thinking I could dig it out of here quick to show it. This is the one extension I had in there. That's like a 4 gauge wire. It's just a short piece. Like this had 2 ends. I cut it in half because I wanted to inspect it. It got a little crunchy inside actually from my couple test rides I've done. The OEM 0 wires, phase wires out of the motor, I believe are either 0 watt or 1 gauge. And what I'm putting in is this stuff, which is 1 aught. Yeah, nonetheless, this can be a good step up. So I'm making new connectors right here. And yeah, this is a little bit ugly. What this is I think it's called an Overtech overmolding gun. Nonetheless, it works really nice. I made a bit of a gobby mess here just to support the phase wires that come out the side cover of the motor. So now what I'm going to do is basically I've just also I'd use the barrel to join the new 1 aught wire with the old connection, which is either 1 gauge or 0 aught. This is actually tight to get in there. It's going to take probably 2 hands. I shouldn't mess those. I don't want to fray those while I'm messing around. I'll do that later. But yeah, I'm making one solid connection here. Then I'll make probably some proper heat shrink over it and everything. And then from there, this will get peeled out eventually. And I have a company called Epic Resins in California, actually in the Bay Area, supplies all kinds of big companies like Tesla, GM, Zero, a bunch of companies with resins for doing all kinds of cool stuff like motor potting, so controller potting, all kinds of stuff. Anywhere that you want to make some sort of potting for whatever reason. So a lot of newer motors now pot their windings with this basically 2-part resin that it's an epoxy resin that pots the windings and basically glues them together to hold them from vibrating. But the big reason most companies like to do it is because that potting is a thermoconductive potting, and it's able to take heat and move it from the windings themselves into the case. So if you've ever had an electric motor apart, and I'll try and maybe pop a picture into this video so that hopefully we can show what it looks like. The windings themselves are enamel wire, which is coated with a electrically isolative coating, and that's a little bit easy to chip off. So what most companies do is they use slot paper, which is super strong paper. You can't tear it. Like I don't care how tough you are, it's really hard to tear. You have to cut it with scissors or something. But you slide that between the stator laminations, and then you slide your enamel wire through that as you're winding your motor. And for that reason, the windings of the motor don't conduct heat into the stator or to the case very well. And so what most of the way the heat gets out is either from radiation, and basically the windings get a little warm and the heat radiates out to the case, or B, some windage, a little bit of air movement inside there from the rotor and everything moves some stuff around, and like air is not a great conductor of heat. So the best thing you can do is pot the windings, and for that reason I've contacted Epic Resins, and they're gonna supply me with some stuff. I'm just waiting for him to get back to me in email. Basically, he was off for Christmas holidays when I finally responded, but I'm gonna get a supply of some potting for potting this motor. And when I do that, I'll pot these wires that come out here too to electrically isolate them. And I have some plans for some other things there. And I'll also pot the leaf motor that's gonna go in the back of the CRX. Probably I already have one in there. I have two in the dyno right now for testing, but the one in the back of the CRX I'll actually take out. I'll basically hand pot the windings as best I can on each end of the stator to help get the heat into the casing better, because then when you liquid cool it, you're actually pulling the heat out of the windings better that way. Nonetheless, the final step, I'll probably, if I have to, I'll use some more of this over molding stuff. It's pretty good. It's like a hot glue gun, but it has to go like 450 degrees or something to melt. It's pretty hot anyway. It burns the hell out of your fingers. Don't try and play with it like a hot glue gun. And then I'm going to also 3D print some little clips to hold the wires together, make it all elegant. So tonight, I decided I'm going to make an attempt to start redoing these phase wires. I just wanted to get started because I'm too damn excited. I can't leave this thing alone. Like I'm like a kid again. I feel like I'm in my 20s, so excited to build something. This bike is so fun to ride, and it's not just because of the power, it's because it has everything. It's a fun chassis. It's got the weight distribution where it needs to be. The roll center is good. The handlebars, the foot pegs, the seat height, all of that is perfect. So right now I'm actually shrinking my dyno down. This is the top platform I made so that I could fit things like open wheel race, like little dwarf cars and stuff on there, or ATVs, and just run one wheel on the roller where the squares cut out over there. Unfortunately, shop space is incredibly expensive nowadays, and the shop I rented leased for over 10 years got bought by a dude who put a grow op in there essentially. So nonetheless, looking to buy a new house with a big shop or something, but in that meantime I'm going to shrink it down so it's actually just the width for regular motorcycle dyno stuff, and that'll be good enough. And at least then I can set it up in the garage and do some tests, and it'll be a little lighter to carry around and be able to store it a little easier that way as well. Some people, when they see some of the things we build in these videos, they don't really realize the work that goes into some of this stuff. I brought in a double disc cutter that has opposing rotation discs. I use this for cutting, if it zooms there, for cutting aluminum. And I use some cutting wax that I have here, and then so that's what I cut this top checker plate aluminum with, and then basically did a zip along the whole length of it there. And from there I gotta cut the one long tube off the side there and leave the two standing posts on it, and then basically take the checker plate off that. But in order for that to fit on there, I had to cut these 4 back, that 1.5 inches, or is it 2 inches, whatever, the thickness of that one tube, so it can come all whole length. So stuff like this, you know, trying to cut these off with a 4.5 inch cutting disc on a 4.5 inch angle grinder, you know, that's challenging, some of that stuff. So it takes some time. This is a whole day project. I kind of came in, you know, at 4 o'clock, so I'm gonna make whatever progress I can before dinner and head home to spend time with the family. It's almost like I knew what I was doing. It's a little tricky to do with one hand. Just like that. Essentially, there we go. Just gotta weld that on there quick, and that part's done. I can haul it home. So some of the other things that I've been upgrading since running this dyno a couple of years ago is the Arduino that was running it. So basically, this takes the signal. I put a optical sensor on the dyno. So basically, down here through this window, when I spin the roller, you can see that lines up at some point to an optical sensor right there. It's actually kind of hard to see in the dark.
Anyways, it's behind that one window in the sprocket.
Tried all kinds of things to make that work well. Originally, this simple Dyno software was actually designed to work with a headphone jack on your laptop or whatever, and it would read some sort of sensor you could put on there. So I put a sensor, like a VR sensor, sensing every tooth on the sprocket. I welded on the end of the Dyno shaft, but that was inconsistent. So, and I really wanted lots of samples per revolution, but what I ended up with was an optical sensor looking through those little windows on there. And so what I've been doing is upgrade all this stuff. Like this is a 900 amps current sensor I was using. I'd run one of the DC wires through there. Then I had to have this power supply because this likes a minimum of 6 volts, I think it is. So I put it to 10 volts with a voltage divider, spitting a 0 to 5 volt signal out. It's 2.5 volts at 0 amps. It goes up from there with positive amps and down from there with negative amps. So that'll read regen and everything. So that's pretty cool, but a big mess of wires. The old Arduino, I just left it. I programmed the new one just so I can keep all the settings in there the way they were. And what I've done is, and a voltage divider. So this, I've just soldered in these alligator clip test leads so I can actually put them on the positive and negative of the battery pack so that it can actually read battery voltage. And this is a voltage divider, so at fully charged it's like 3.88 volts spit into the Arduino. So this voltage divider is actually good for up to about 150 volt battery pack, which is nice to have a little buffer because during regen you might get a spike above 119, 120 or something. So nice to have a little extra there. And then basically I'm going to use one of these blue current sensors, these LEM 600 HASS 600S. I'll use one of these, and because these accept 5 volts input, and I'll hopefully fit this over one of the battery wires without modifying anything, and basically just run the signal straight to the Arduino. So that means Arduino can power this. I don't need the power supply anymore, and get rid of all this mess of stuff, make it a lot nicer. Sometimes when you're putting things together, you find that whatever you're using isn't working correctly. So this Arduino that I was trying to use for some reason had input from A1 getting crossed to A0. So basically A0 I use for my voltage divider for the input of the voltage divider from the main battery pack. And A1 is the current sensor signal, which should be 2.5 volts. And on this one I was able to measure right at pin A1 2.5 volts, even though my program, my simple Dyno program, was actually telling me that it was at 3.6 volts. So there was a problem with this board. Probably have to make a little note. I'll write on it with a felt marker, but essentially I'm resoldering everything to this board. So far it seems to be working. I just got to add the wheel or the roller speed sensor, and then we'll see if it works. All right, here's the first run. Oh, I was wondering why I was smoking the tire, and it's actually the roller that's trying to keep pushing it. All right, just gonna try another run here quick. Sorting out stuff with the dyno. Let's see what happens. Just going to do another run here. This time I've increased field weakening, and this gauge here is going to show us the contactor voltage drop. We have suspected that the contactor's weak. So if we see this go to like 1 volt or above, we're going to shut down. As you can see, I got my safety slippers on. They're really good for dyno testing in the garage at home. It's midnight, Saturday night, still working on the dyno. Just solid mounted my, I found a hall sensor on my wife's bike. I was using optic sensor on this. I think the optic sensor is probably okay, but everything's always in question when you have unclear RPM data. So what I did was I stole the hall sensor from the front speed sensor for my wife's motorcycle for now. I'll see if I can replace that or get another one. And then I solid mounted it to the dyno here. This mount is the hall mount, and then I just welded a bolt here to spin past it. So you'll see it spins like that. And you'll see as it gets there, the little LED shuts off and then turns on as it goes past. I did have it mounted on this bracket, but it's a little bit flexible, and I'm thinking maybe some vibrations on that. It's causing me some sort of issues. So I'm just trying to do like a partial run up just past 3,000 RPM full throttle to see if I can show if there's any noise or not. Hopefully it doesn't piss everybody inside off. Good chance my wife's not sleeping yet, but I have to make this. I have to try, because I have to know if I need to add caps and stuff and a bunch of other noise filtering methods. So I'm gonna go for it. Okay, so just get that on this voltmeter. I've just got it across the contactor. Contactors give me a couple of issues, so mostly just being welded. Originally I had the pre-charge level set to 90%. I bumped it all the way up to 97%, so hopefully that helps a little bit. Everything should be live. So I've got this ready to save. I'm just gonna get it going a little bit, and then I'll pin it for a brief period. I think I finally have data that I can use. None of this looks too spiky anymore. What it is torque at the rear wheel times speed or RPM. They're essentially the same thing. Gives you your acceleration. So basically, if you have lots of torque at zero speed, that's great. It'll get you off the line good. But if it falls away right away and you don't have any torque at higher speeds, you're going to only accelerate off the line really good. Kind of like that little scooter that I made for my brother. Has 330 foot-pounds of torque at the rear wheel, only to like 10 kilometers an hour, and then it falls down to top speed of 50 kilometers an hour. But torque times speed, which this has over 450 foot-pounds of torque, somewhere around 550 miles an hour still, something like 3,800 RPM or something like that. That's how you get a horsepower number. So horsepower is king. So 58 horsepower is pretty damn good. It could probably make a little more with the right, I don't know if I can do any more with the Sevcon size 6. It needs to shove more current into the motor. Also, this battery is a little bit limited. Pulling around 500 amps out of the battery, staggering around 104 foot-pounds of, 104 volts at the battery. One thing I'd like to mention is accuracy of your dyno is very critical, and a good friend of mine pointed out that I needed to look at my plots because I had a lot of smoothing in them, and I didn't realize it did at first. So then I did some digging and went down a huge rabbit hole, spent like probably 20 hours of R&D on the dyno sensor so I could sort that out to make sure this is as accurate as possible. This dyno is actually very accurate, and it's repeatable too. That's the other thing. I'm able to change timing 5 degrees, show that it makes horsepower to higher RPM but less horsepower peak. I can also go the other way and it makes a little horsepower. Actually, it didn't make any lower, it just made less horsepower everywhere when I changed the time the other way. But I can change some settings and show that it changes, then go back and it gets the same numbers repeatedly. And that's very important with the dyno. It's not just about making, peak horsepower. it's about making the horsepower, you know, repeatedly, but also if you're finding gains, being able to repeat those gains, so that if you make 10% gain, 10% is 10%. If your customer comes in and goes out with 10% more power at the wheel, he's going to be happy, or she, whatever. It doesn't matter. It's more about just having a repeatable gain. So if you come in with 3 bikes that are identical, they all make the same power at the rear wheel, and you're able to tune them and they make 10% more at the rear wheel, and your dyno shows the same numbers, that's repeatability, and that's an important thing. So there's quite a few factors at play, especially like in an electric. They're pretty consistent, but battery voltage and battery temperature is a very critical thing. So you need to have a fully charged battery that's warmed up. So most of my runs are between 20 and 30 degrees Celsius. I try to always make sure my battery's up to temperature. That's a critical thing, and always have it charged for the runs. I do what I can to regen back down to put some energy back out of the dyno back in the battery, but with a fully charged battery, you can't capture too much of it, so I really beat on the brakes. I should put a mechanical brake on the dyno at some point. I'm just afraid of having anything that has any sort of drag. I've always considered maybe some sort of eddy brake or something I could add to it, but anyways, things are going good right now. The dyno from the data is definitely a lot better. This little bit at the end here, we can't trust that. So what I can do is I can do one of two things. I can smooth it more like this.
Avery's sleeping.
There we go. Now. I want to do that before the battery cools off and everything. So we have a pretty good fitment. This little bit here, I'd like to try to get the whole, oh yeah, I was moving the wrong one, damn it. Trying to get a little bit of smoothing in there. 3 has been the number, but the start fitment number, start at 1. Doesn't look super good, but start at 2 is decent. So we'll go with that. So there, now you can see, you know, the torque comes up, hits a peak here, around 635 foot-pounds of torque at the rear wheel. But it's, the RPM is more accurate now, so that all makes more sense. Oh man, the whole time I've been using the wrong RPM. So nonetheless, peak horsepower, 58 horsepower. Yeah, baby, 58 horsepower. Pretty flat horsepower curve there. Torque is basically flat from here over to here, something like that. So we can't show that because the dyno needs more sensors per revolution. Max torque at 635, that's pretty accurate. It might be maybe within, you know, could be 10 foot-pounds less, but it's over 600, I'm sure of it. Just to show, we can change this to speed. Whoops. So we'll go to speed, and then we'll go to miles per hour. I've always been saying it, wheelies, at power wheelies, you know, somewhere up to 50 mile an hour, and at 49.4 miles an hour, it still has 462 foot-pounds of torque at the rear wheel. So at highway speeds, this bike has more torque at the rear wheel than that middle black bike does at any point. So this thing is a total rocket. It's insane. 58 horsepower is pretty amazing. Like, I'm not gonna, you know, I was expecting more, but I think basically the battery voltage sag, you can see it sags to only 105, so that's not horrible, but if it could stay a little stiffer, it'd be better. I think a controller that could let me shove a little more field weakening, or a little more, you know, change some things. I've played with timing events, I've played with a bunch of things, but this is kind of the highest numbers I'm going to get. I'm able to make it rev out a little better, but you know, we're pulling 50 horsepower still at 74, 75 miles an hour. And like, how many motocross tracks are you going to be doing 70 plus miles an hour on? This thing would be a supermoto god. Like, I'm not kidding. Basically, you'd be able to pull power wheelies past a lot of the other riders, you know, at highway speeds and set it down for the next corner. So this is an incredible bike. I'm super excited for it. Everything's looking really good. A max horsepower of 58 horsepower. That's pretty freaking exciting. Before I forget, now that I've done a bunch of runs on this, we'll get a few cool thermal imaging pictures. You can see the chain, it's getting up there in temperature a little bit. That's part of the trick, having that chain nice and warm. The battery itself, if we look, you know, battery's around 34, 33 degrees Celsius. Motor controller, not too hot or anything. Rear disc, I have to service the rear brakes. It's pretty warm. Wait, did I see a max of? I thought I saw a max of like 200 and something, but maybe I was incorrect there. Must have been 20 something on the spot. Anyways, this thing's pretty fun. You can come around, you can look, you can see the heat in the middle of the tire. If you zoom in a bit, try and get the chain on the tire, you can see the center of the tire is a little hotter. Even the dyno roller, you can see where there's a bit of heat in the middle. It's kind of hard to see because it reflects so easy. The chain's got a bit of warmth to it. Motor, again, 40 something degrees. It's cooling fairly well. Let's look at the heatsink of the controller. This is after, you know, 15 or 20 repetitive dyno runs back to back. Basically, shut it down, change the setting, run it again. I'm just trying to look for anything obvious that has issues. I don't see anything really bad. Have a contactor I have to change, only because it has welded itself probably 10 times now. And I think what happened was I had my pre-charge level set to 90% and I should have had it at 95 or higher. I set it to 97 now, but I think it's too late. It doesn't make a hard click anymore.